Hi everybody, this is going to be the first video of chapter 2. So chapter 1 we talked a lot about solving equations. Now we're getting into solving inequalities. Now there's a lot of common things between equations and inequalities that we'll get into later, but I want to start off just talking about some of the inequality symbols, what they look like, and how we would actually write that inequality in words, how we would say it out loud if we were talking about it. So along the top row here, I have 4 different inequality symbols. Below, we're just going to write what they're actually saying. Okay, now, the first one that we have here is actually saying x is greater than x is greater than 2. Okay, so whatever x is, it's bigger than what 2 is. It's not the same as 2. It's not equal to 2. It's just bigger than 2. It could be 2.1. It could be 3. It could be 1,000. Anything greater than 2. Now, the one next to it, you'll notice looks similar, but there's this little bar underneath of that greater than symbol. So this is telling us that whatever x is, it's going to be greater or equal to 2. So x is greater than or equal to 2. So now x could be 2, it could be 2.1, it could be 300. Anything greater than or equal to 2 would be correct. Now the last two here, we've got x is less than 2, so smaller. So 1.9, 0, negative 12 would all be less than 2. And then our last one, we have x is less than or equal to 2. So anytime you have that little bar underneath of your inequality symbol, it's the equal to part. It's including the number. So that's how we would actually say all of these. Now, the big difference between inequalities and equations is most of our equations only had a single solution. We found like x equals 2, and that was the only solution to the entire equation. With inequalities, there's going to be a lot more. If I tell you that an equation has solutions of x is greater than 3, that means that any number that's bigger than 3 would work for my equation, or my inequality in this case. So there's going to be more than one solution when we're solving inequalities. There's going to be a lot of solutions, and we're going to actually graph all of those solutions using a number line. Now, to actually graph, you've got some steps here. So how to graph. The first thing that we're going to do is we're going to put a circle above the number that our solutions begin at. So I'm going to work an example below here while we're going through these steps so we can kind of make sense of it as we go. So if I have x is less than 3, I'm going to, first of all, number my number line so that I know where 3 is. So typically, I'll take whatever number is here, and I'll put that in the middle of my number line. So that's 3. Now, as we move to the right on our number line, our numbers are going to get bigger. And as we move to the left on our number line, our numbers will get smaller. So here's our number line with 3 in the middle. So the first step again said put a circle above the number your solutions begin at. We're going to use a closed circle if we have one of the greater than or less than and equal to symbols. But if we just have the less than symbol or just the greater than symbol, like we have right here, then we're going to use an open circle. So we're going to put an open circle above 3 like this. And then we're going to draw an arrow pointing to the direction where we find our solutions. So for this example, our solutions are x values that are less than 3 or smaller than 3. So I want to point my arrow in the direction of the numbers that are smaller than 3. So to the left. and that would be our solution. Okay, we're graphing, showing all of the potential solutions to this inequality. So let's look at another one. Right? Our solutions are greater than or equal to -4. So I'm going to put -4 in the middle of my number line here. To the right, they get bigger. So be careful with negative numbers. As they get bigger, they get closer to 0. So -3, -2, -1. And as my numbers get smaller, as I go to the left, it's going to get farther away from 0. So here's my number line. We know we're going to put a circle above -4. We just have to decide if it's going to be closed or open. So since we have a greater than or equal to symbol right here, that means we're going to use a closed circle. So we're going to put a closed circle above 4. So we're just going to fill it in. And then we have to decide which way our arrow goes. So we want the x values that are greater than or equal to -4. So the numbers that are bigger than -4 are to the right. So we're going to make our arrow go to the right. So this is an example of how you just graph your solutions. Now this is what you're going to do at the end of your problems. We'll actually have an inequality that we solve. We'll get our solution, and then we'll graph it like this. All right, so let's take a look at how we actually solve an inequality. So they're going to be basically the same as solving equations. The only difference is that our equal sign that we have in an equation is being replaced with one of these inequality symbols. So we have less than, greater than, less than or equal to, or the greater than or equal to symbol. Okay? Now, here are some super important rules that you have to follow, or recommendations, I should say. The first one is a must. When you divide or multiply by a negative number, when you're solving an inequality, you have to flip the sign. Okay, and I'll explain what I mean there. So that one is a must. The second one's more of a recommendation. My second thing here is I would collect the variable to the left side of your inequality. That's just it's just my personal preference. I think it makes it a little bit easier when you're trying to interpret your answer. Okay, so I'm going to recommend that you keep your variable on the left side of your inequality to get your final answer. So let's solve here and see what I mean by flipping the sign. Okay, now just like with equations, I want you to find your inequality symbol. So in this case, we have a greater than symbol, and I want you to just split it down the middle from there. We need to establish two sides. From here, we're going to go about solving it just like we would an equation. We have some parentheses, and we have a -3 in front that we're going to distribute. So we have x minus 3x minus 6, and then we're going to go ahead and copy that symbol that we have down, so greater than 4. So instead of an equal sign, we're using our inequality symbol. Now we're going to go back through and we're going to combine these x's. So we have -2x minus 6 is greater than 4. We're going to add 6 to both sides. And here's where the flipping the sign comes into play. So at this point, to solve for x, we need to divide both sides by -2. Anytime you divide by a negative number or you multiply by a negative number, you have to flip the sign. So that greater than sign that we've been using this whole time is going to flip over and become a less than sign. 10 divided by -2 is -5. So here's the solution to this inequality. Okay, if you look at the original inequality that we started with, any number less than -5, if I plug it in, is going to make that inequality true. So let's just do a little test here. Okay, I'm going to pick a number that is less than -5. So let's use -6. If I plug -6 in for x in my inequality that I started with, let's see what happens. we would get negative 6 minus 3 times negative 6 plus 2 is greater than 4. Okay? Let's use some order of operations here. I have negative 6 minus 3, and then inside my parentheses, negative 6 plus 2 is really negative 4. Okay, let's go back through. Let's do multiplication next. So negative 6, and then I have a negative 3 times a negative 4, which makes a positive 12. Negative 6 plus 12 gives me 6. And I get 6 is greater than 4. So this is true. Okay, it makes that inequality true. If I pick any number that isn't less than negative 5 and plug it in, it's going to give me an inequality that isn't true. It might give me something like 2 is greater than 4, which is not correct. So let's look at one more example, and that's going to be it for this video. Make some space here. So just like last time, we're going to find our inequality, and we're just going to split it down the middle. Now, we don't have any distributing that we need to do this time, but we do have variables on both sides, and we need to collect them to just one side. Now, remember my recommendation. Number 2 said we should collect the variable to the left side of our inequality. So this 5x that I have on the right side, I'm going to cancel out. I'm going to subtract 5x from both sides. So now I have 2x minus 5x, which gives me a negative 3x minus 1. It's less than or equal to 20. And then I'm just solving it like normal. I'm going to add 1 to both sides. Oh, that's the wrong color. We're going to add 1 to both sides. And now we have negative 3x is less than or equal to 21. And then we can divide both sides by a negative. So here comes in rule number 1. Whenever I divide by a negative number, now I need to flip the sign. So it becomes x is greater than or equal to negative 7. So that means that I can plug in any number that's equal to negative 7 or bigger than negative 7, and it's going to make my inequality true. So let's do a little test here. We know that 7 should make the inequality, or I'm sorry, we know that negative 7 should make my inequality true, and we know that numbers bigger than negative 7 should make the inequality true. Now keep in mind, numbers bigger than negative 7 would be negative 6, negative 5, 0, 10, and so on. So let's pick a number that's smaller than negative 7 and see what happens when we plug it in here. All right, let's pick negative 10. Negative 10 is smaller than negative 7. So let's see what happens when we pick a number that's smaller. So if I go back and plug negative 10 into my original inequality, I'm going to get 2 times negative 10 minus 1 is less than or equal to 5 times negative plus 20. So then we just start using our order of operations to simplify. 2 times negative 10 is negative 20 minus 1 is less than or equal to, and then 5 times negative 10 gives us negative 50 plus 20. Okay, go back through, simplify one more time. Negative 20 minus 1 is negative 21, and that should be less than or equal to negative 50 plus 20, which is negative 30. Now right here, it's saying negative 21 is less than or equal to negative 30, right? Negative 21 is greater than negative 30, okay? So this is not true. So you can see that when I plug in a number that was smaller than negative 7 in this case, it made my inequality false. It gave me something that isn't true. Rather than what we did in our first example, okay, going back to our first example on the left, we found that our solutions were any value smaller than negative 5. So when I picked a number smaller than negative 5 and plugged it in, it made it true. So that's really what's happening with inequalities here. There are multiple solutions. There's actually an infinite number of solutions to every inequality. We're really just trying to figure out, where do our solutions start? Okay, what numbers are going to work and which ones won't? All right, so don't forget, pause the video, rewind, rewatch, and make sure you ask questions. Have a great day.